Orcas hunt not by overwhelming force, but by interrupting biological systems at their weakest point, exploiting survival rules so precisely that collapse becomes automatic rather than violent. Their intelligence is metabolically expensive and emotionally indifferent, evolving not for empathy or curiosity, but to compress risk, energy loss, and uncertainty into the smallest possible margin. As warm-blooded predators in cold water and highly social hunters, they survive by running tightly coupled systems with no true backup, where efficiency replaces resilience. Even their restrained interactions with humans and their increasingly specialized cultures reveal the same pattern. A life form that should fail under its own precision, yet continues by balancing perfectly on the edge of its limits. Movement is not optional here. It is the price of staying alive. The moment it stops, the oxygen supply collapses. The brain starves first, then everything else follows. And yet something interferes with that motion without tearing flesh or crushing bone. This contradiction exists, and it works. The organism involved is the orca. Not faster than every predator, not larger than every threat, but precise in a way that biology rarely tolerates. A great white shark survives by perpetual motion, ram ventilation, forcing water across the gills, a design that trades rest for efficiency, a system balanced on the assumption that forward movement will never cease. Orcas do not attack that system head-on. They do something quieter. They flip the shark. For a brief window, blood pressure drops, neural signals misfire, tonic immobility sets in, a reflex meant for short-term survival becomes a terminal vulnerability. The shark's body does not understand the context, it only follows rules written into its nervous system millions of years ago. This is not strength defeating strength, it is one biological protocol interrupting another. Energy expenditure is minimal, risk is limited. The shark does not bleed out, it simply fails to reboot in time. The unsettling part is not the kill, but how little force is required once the correct constraint is applied. This strategy should be rare, because it depends on intimate knowledge of another species' failure modes, knowledge that must be learned, remembered, and transmitted. Yet it spreads. Populations separated by thousands of kilometers exhibit similar behavior, suggesting not coincidence but cultural inheritance. Biology usually punishes excess cognition because brains are expensive, metabolically greedy organs that demand constant fuel. Orcas pay that cost anyway. Their caloric intake must sustain not only muscle mass and thermoregulation, but a nervous system capable of long-term memory, planning, and behavioral innovation. There is no safety margin here. A failed hunt is not an inconvenience. It is a measurable step toward starvation. And still, they invest in precision rather than brute force. The horror is subtle. A predator that does not escalate violence, but reduces it because the environment rewards efficiency over spectacle. This is not intelligence as curiosity or play, it is intelligence as compression, finding the shortest path between stability and collapse in another living system. When observers describe this as cleverness, the word misses the point. There is no admiration embedded in the behavior, only adherence to physical limits. Blood oxygen levels fall, neural inhibition spreads, muscles lose tone. The sequence is automatic once triggered. The orca does not need to understand it emotionally, only operationally. The ocean does not react. It does not register injustice or imbalance. A body stops moving because the rules governing that body allow it. That is the true discomfort. Nothing supernatural occurs. No boundary is broken. A perfectly valid biological design is simply pushed into a corner case it was never optimized to escape. The system fails silently, not because it was weak, but because it was too specialized to imagine interruption. A brain of this size should be a liability, every additional fold demanding oxygen, glucose, constant circulation, constant repair, a metabolic tax that compounds with age, and yet it persists, not trimmed back by evolution, not simplified for safety. This contradiction holds. In orcas, intelligence does not emerge as excess. It survives because it pays for itself with unsettling efficiency. Learning is not abstract here. It is not curiosity. It is calibration. Every successful hunt reinforces a pattern. Every failure subtracts energy from a narrow survival budget. There is no room for prolonged experimentation, and still, new behaviors appear. Orcas observe outcomes, not intentions. They track what works, not why it feels right. When a hunting method reduces energy loss by a small percentage, that difference matters over decades. A large brain becomes acceptable only if it prevents catastrophic mistakes. This is where the discomfort begins. Intelligence is often framed as a buffer against extinction, but here it behaves more like a sharpening stone, removing redundancy, smoothing behavior down to its most efficient edge. Cultural transmission accelerates this process. Knowledge is not rediscovered each generation. It is inherited, compressed into behavior before individuals are fully mature. A young orca does not need to test every possibility. It is shown which ones fail. This reduces risk, but it also removes hesitation. Evolution usually favors caution because errors are fatal. Orcas outsource caution to memory. The result is a predator that can approach the limits of its own physiology with confidence, because the margin of error has already been mapped by others. The brain becomes a storage device for past collapses, a library of near deaths that no longer need to be repeated. This should be unstable. Large brains are vulnerable to hypoxia, to trauma, to developmental failure. They require long childhoods, extended parental investment, years of non-productivity. In most environments, that delay is punished. But in the ocean, where prey distribution is unpredictable and mistakes are costly, foresight becomes currency. The horror is not that orcas are smart, but that their intelligence is not softened by abundance or safety. It is shaped by scarcity and consequence. There is no evolutionary incentive for empathy toward prey, only for accuracy. When humans interpret orca behavior as playful or curious, they are projecting traits that are metabolically expensive and biologically unnecessary. What exists instead is a decision-making system tuned to reduce wasted motion, wasted force, wasted time. The brain does not seek novelty, it seeks compression. Fewer moves, fewer variables, fewer unknowns. Intelligence here is not an expansion of possibility, but a narrowing of it. A mind that survives by learning exactly how little is required to end another system, and then repeating that lesson until deviation becomes unlikely. This is not cruelty, it is optimization under constraint. And optimization, once it begins, does not ask whether the result feels excessive. Heat should leak faster than it can be replaced, not gradually, but relentlessly, pulled away by water that does not negotiate, a medium that drains energy 20 times faster than air, and yet the core temperature holds. It should not, but it does. Orcas are warm-blooded bodies moving through an environment designed to punish that choice. Every second, heat flows outward. Every second, metabolism must respond, converting chemical energy into thermal stability with no pause, no off switch. This is not comfort, it is containment. The internal temperature of an orca must remain within a narrow band for nerves to fire correctly, for muscles to contract on time, for the brain to maintain coherence. A deviation of just a few degrees would not be dramatic, it would be catastrophic. Reaction time slow, coordination degrades, judgment falters. The margin is thin, and the cost of maintaining it is constant. Blubber is not insulation in the passive sense. It is a reservoir, a buffer that slows loss, but does not prevent it. Blood vessels are arranged in countercurrent heat exchangers, arteries warming veins before heat can escape into the sea, a design that works only as long as circulation remains precise. There is no room for circulatory error. Shut down the flow, and tissue cools. Increase it too much, and heat bleeds away. The system must run continuously, balanced between conservation and dissipation. This should be unsustainable over a lifespan measured in decades. A warm-blooded predator of this size requires enormous caloric intake just to remain thermally neutral. Hunting is not optional. Rest is not neutral. Even stillness costs energy. Sleep does not reduce the bill. The body burns fuel even in inactivity because the environment never stops pulling heat away. The unsettling part is not that this works, but that it works without redundancy. There is no secondary mode, no fallback state. If food becomes scarce, the body does not gracefully downshift. It consumes itself. Fat reserves shrink, insulation thins, heat loss accelerates, metabolism increases to compensate, burning more fuel to fight a problem caused by having less fuel. It is a feedback loop that ends quietly. No struggle is required. No predator intervention, just arithmetic. Warm blood in cold water is a decision evolution usually avoids because it magnifies every mistake. Orcas persist because their hunting efficiency remains high enough to keep the system running near its limit without crossing it. The horror is in the balance. A body engineered to operate at full load for decades, never cooling, never coasting, never allowed to be merely adequate. When observers describe orcas as powerful, they miss the more fragile truth. Power here is not excess, it is precision. A metabolic engine tuned so tightly that survival depends on uninterrupted performance day after day, year after year, in an environment that would prefer it fail. Cooperation should slow violence, it usually does. Social species tend to dilute risk by spreading responsibility, hesitation creeping in as individuals account for one another, and yet here coordination sharpens the outcome instead of blunting it. This contradiction holds. Orcas form stable, long-term social groups where individuals are rarely alone, where survival depends on synchronization rather than independence. Every member carries weight. A mistake is not isolated, it propagates. In most biological systems, that level of interdependence favors caution. But in this case, it removes it. Group hunting allows roles to specialize. One individual distracts, another blocks escape, another delivers the precise interference that ends the process. No single body bears the full cost of the action. Energy expenditure is distributed, risk is averaged out. The system becomes more aggressive not because individuals are reckless, but because the group can absorb failure without collapsing. Social bonds here are not emotional safety nets, they are structural reinforcements. Calves learn by proximity, not instruction, absorbing patterns long before they understand consequence. By the time they participate, hesitation has already been engineered out of the sequence. This is efficient and deeply uncomfortable. Social learning accelerates behavior beyond what individual trial and error would allow, compressing generations of selection into a few observed outcomes. The group remembers what works and forgets what does not. There is no internal pressure to question whether a method is excessive. Excess is irrelevant if it reduces uncertainty. In environments where prey can injure or kill, predictability is survival. The group does not bond to soften the act, it bonds to stabilize it. This should be dangerous. High coordination means shared failure modes. Disease, food scarcity, or environmental disruption can cascade through tightly linked populations. Orcas accept that risk. They trade flexibility for reliability. The horror is in how cleanly this mirrors engineered systems. Redundancy is not added to protect prey or preserve balance. It is added to ensure task completion. Observers often mistake this cohesion for morality, reading restraint where there is simply selectivity. The group does not kill indiscriminately, not because it is gentle, but because unnecessary actions waste energy. Sociality does not humanize the predator, it mechanizes it. A network of bodies moving as a single decision-making unit, reducing noise, reducing variation, reducing mercy not by intention, but by design. This interaction should end immediately. Misjudgment at this scale usually does. A large predator approaching an unfamiliar organism carries asymmetric risk, and yet contact occurs without escalation. It continues. Humans are not part of the orca's natural diet. That fact is often framed as safety, but biologically it is something else. It is irrelevance. Orcas evaluate objects in their environment by payoff, not by novelty. An unfamiliar shape in the water is not automatically prey, but it is not automatically exempt either. Investigation costs energy, injury costs survival. The balance between those two determines behavior. In many documented encounters, orcas approach humans slowly, sometimes touching, sometimes disengaging. This is not curiosity in a human sense. It is assessment under constraint. A human body does not resemble known prey profiles. Fat distribution is different. Movement patterns are inefficient. There is no immediate signal that this object can be processed into usable energy without risk. The predator pauses not out of kindness, but out of calculation. This is unsettling because it places human safety on a thin, shifting foundation. There is no recognition of personhood, no moral boundary. There is only cost-benefit analysis running in a nervous system shaped to avoid unnecessary damage. The same intelligence that disables sharks with minimal effort is now applied in reverse, minimizing engagement instead of maximizing it. Play-like behaviors, such as carrying or pushing objects, emerge in species with high cognitive capacity, but they are still bounded by energy economics. When an orca nudges a human, it is not testing empathy, it is sampling. The interaction persists only as long as it remains low cost. This should not feel reassuring. It means the absence of aggression is conditional, not principled. Change the variables, hunger level, group composition, environmental stress, and the evaluation could shift. The reason widespread attacks do not occur is not restraint, but consistency. Humans remain a poor return on investment. The horror lies in how fragile that status is. Safety is not granted, it is temporarily calculated. Nature does not offer protection out of familiarity. It tolerates presence only while it remains inefficient to remove it. The interaction feels gentle because the system has no incentive to escalate. That incentive, however, is not permanently absent. It is simply dormant, waiting for a change in numbers. At a certain point, additional intelligence should stop helping, diminishing returns setting in. As neural tissue grows heavier, slower, more fragile than the problems it solves, and yet the expansion does not halt. Orca cognition appears to push beyond immediate survival demands, developing memory depth, vocal complexity, and behavioral flexibility that exceed what is strictly necessary to hunt and reproduce. This is where the unease sharpens. Evolution usually trims excess. Anything that consumes energy without clear payoff is removed over time. But here, the mind continues to elaborate. One explanation is that the environment itself is unstable enough to reward constant adaptation. Another is less comforting. The system may be overfitting. In machine terms, it is learning patterns so specific, so optimized to past conditions, that it risks brittleness under change. Cultural knowledge accumulates faster than genetic change can buffer it. Behaviors are refined, specialized, perfected for niches that may not persist. A mind tuned to extreme efficiency becomes vulnerable to novelty it cannot compress quickly enough. This is not hypothetical. Orca populations show distinct cultures, prey preferences, and hunting techniques, some so narrow that shifts in prey availability lead to rapid decline. Intelligence does not guarantee resilience. It can concentrate risk. The brain, in this case, is not a general-purpose solution. It is a high-performance component running close to its tolerance. The unsettling possibility is that evolution has allowed cognition to outrun safety margins because the short-term gains were too effective to resist. A system that works beautifully until it doesn't. There is no external safeguard, no awareness of trajectory, just a feedback loop that rewards success right up until the conditions that define success disappear. When humans ask whether orcas are becoming too smart, the question misses the mechanism. There is no threshold where intelligence becomes dangerous in itself. There is only a point where optimization locks a system into assumptions it can no longer afford. The horror is not that the mind is powerful, it is that it is precise. Precision reduces tolerance for error. In a changing ocean, that trade-off becomes visible. A life form that should not exist, because it operates with so little slack, continues anyway, balanced on accumulated knowledge, burning energy to maintain a model of the world that must remain accurate to avoid collapse. Science does not call this tragic, it calls it adaptive, until the moment it isn't.